So let's go ahead and get started. Really happy to be here. I have actually spoken on this topic quite a few times to different substance misuse prevention groups around the country. And I'm grateful to be here again today. I am a faculty member at the Johns Hopkins Bloomberg School of Public Health. I love talking about generative AI, sharing what I know, because at Johns Hopkins, I teach not only about health science communication, but also courses in generative AI and how we can use generative AI in public health. And I do that because I also have a bit of a computer science background, and for about 25 years, I led a team that builds educational software for Johns Hopkins, including some generative AI tools. And because I work at an educational institution, you can imagine that generative AI is a big topic, which it is. As with practically everywhere else on the planet, you just can't escape the narrative around it. And what we basically hear is that generative AI is either going to make us all super productive and remove all the tedious administrative drudge work we have to do every day, or it's going to take all of our jobs, become our matrix-like overlords, and eventually destroy humanity. But more practically, there are serious concerns about the influence of generative AI on our healthcare, on our well-being, our culture as a whole. Do we want machine learning models making decisions about who gets medical care and treatment? Do we want generative AI taking notes for our physicians that might omit or obfuscate critical patient details? And more generally, do the threats from generative AI outweigh the potential upsides? Because there are upsides. In a study published last year in March by Ethan Mollick and his colleagues at both Wharton and Harvard, they did a randomized controlled trial of 776 white-collar professionals at Procter and Gamble. And they found that individuals performing with generative AI tools perform just as well as entire teams of people working without generative AI, and that teams using generative AI tools were significantly more likely to produce top-tier solutions compared to any other group. So for every potential advancement in using generative AI tools, there's some equal measure of peril. And my objective is that you leave this session today armed with a more critical eye in both using and evaluating the risks of generative AI, and that you walk away with some practical tips on using generative AI in your everyday public health work. So again, as I mentioned before, if you have questions, feel free to type those in the text chat and I'll do my best to answer them. But I want to start with a very high level look at how generative AI works under the hood. And I think this is important for you to know to understand and evaluate the output from these tools. This is not going to be a PhD level approach. This is like really, really high level. So large language models, and large language models are the sort of computer programs that underlie tools like ChatGPT or Claude or Google Gemini. Large language models are actually based on a very simple statistical model. So you can think of ChatGPT or other large language models kind of like how meteorologists predict a hurricane path. So millions of pieces of data go into a system which predicts the path of the hurricane in real time. Now, the system isn't going to be 100% accurate all the time, but it's going to make its best guess as to where the hurricane is headed in the next 24 hours. It uses data to generate probabilities for the path of the hurricane. And that's exactly what large language models that underlie tools like ChatGPT actually do. So the classic definition in computer science of a language model is a probability distribution over a sequence of tokens, or more specifically, words. So let's say we have a vocabulary of words represented by the V here, and then we also have a sequence of tokens of individual words, word 1, 2, 3, 4, 5, and so on. And a language model here represented by P assigns each different sequence of tokens, each different sequence of words, a probability, a number between 0 and 1 that tells us, the users of this model, how, quote, good or accurate a sequence of tokens actually is. So let me give you an example of this. So let's say we have a vocabulary containing 6 words: 8, ball, cheese, mouse, the, green. Then the language model assigns a specific probability to a specific sequence of these words in its vocabulary. So the language model would say that the sequence mouse, the, cheese, 8 has a very low probability score. And the language model would say that the sequence the cheese ate the mouse also has a pretty low probability score, although not as low as the other one. The model would assign a much higher probability to the sequence of the words the mouse ate the cheese. So why would it assign that particular sequence a much higher probability? They're just words strung together, right? Well, the model itself has code, algorithms that evaluate both the syntactic probability of a sequence of words as well as a world knowledge about how these words are used in the real world. And it gets both of these things from its training data, from the millions or trillions of pieces of data that it processes when the model's being trained. And it also gets some foundational knowledge about how the English language works in this case from the decades of research and commercial deployment of dictation software like Siri or Dragon Naturally Speaking, for anybody who remembers that. So the sequence the mouse the cheese ate gets a very low syntactic probability score because the algorithms inside the model say this is not how these words go together in the real world. And the sequence the cheese ate the mouse also gets a fairly low probability score because the world knowledge the models gain through its training also says, no, no, no. Cheese doesn't eat mice, mice eat cheese. But the sequence, the mouse ate the cheese, gets a much higher probability because during its training, it's learned that this sequence has both good syntactic probability and world knowledge probability. So if you type the words the mouse ate, the large language model would probably guess the words the cheese as being the next couple of words because that particular sequence of words has a much higher probability than other sequences of the same words. But it all still boils down to this simple probability. This is how large language models and tools like ChatGPT, Gemini, Claude all work. And remember, these are probabilities, not certainties. These are predictions, not facts. Okay, quick pop quiz, because everyone loves a pop quiz, right? Just to make sure everyone understands these basic concepts here. So you can type your answers into the text chat as we go along. So, how does a large language model like ChatGPT predict the next word in a sequence? A, B, C, or D? And go ahead and type your answer into the chat there, and we'll give people a couple seconds. Yes, B, and everyone's saying B. Excellent. By calculating the probability of word sequences. Next question, true or false? Asking a generative AI the same question multiple times will give you the exact same answer each time. Is that true or false? Yeah, it's false. So the core of the answer might be similar, but the way it's presented to you is going to be different every single time. All right. So now that we all have this sort of like fundamental understanding of how these tools work, and I'm really simplifying things here. I mean, they're much more powerful and complex systems than simple prediction machines, but their core, that's really what they do. So now that we know that, I want to spend probably a majority or big bulk of my time and tips and guidance here today, focusing on helping you use these tools to get better results more quickly, because time is precious and time is the one thing that none of us will ever have enough of. So I'm going to talk for a little while about prompting strategies for better results. And a prompt is what you type into a tool like ChatGPT or Claude or Google Gemini, what you type into that little box. That's your prompt to the tool to do something or give you an answer or generate some kind of output. I'm going to focus on ideation and brainstorming because that's where large language models are really strong right now. We're busy working adults. Having a large language model come up with 50 ideas for a presentation is a whole lot faster, and I would argue ultimately more creative than what we could do on our own because the majority of us just don't have the mental bandwidth to do that kind of work. It would take us hours to come up with ideas for 10 ideas for a presentation, but it'll take a large language model seconds to do that same work. And these prompts I'm going to show you and walk you through are really starting points to conversations. You should absolutely have a conversation with a large language model to refine the output it gives you to suit your needs. And I'm going to show you a lot of one-shot prompts to get through a bunch of examples quickly, but one-shot prompts rarely give you the exact output you need. You're going to need to have to go in and iterate on what the large language model provides for you almost all the time. And by the way, I'll make sure that Tyler has a copy of these slides so that he can distribute them to you if you need them afterwards, so you don't have to do screenshots or anything like that. Because at the end of the day, and I teach this to my students at Johns Hopkins, effective prompt writing is a skill. And like most skills, you can become better at it with practice. You know, we think about our bodies and we're like, we need to exercise, we need to go to the gym, we need a good cardiovascular workout to make ourselves stronger and be healthier and have a better life. We can build those muscles, and writing prompts is the same thing. The more you do it, the better you're going to get at it, and the higher quality output you're going to wind up getting from these tools. And really, I will tell you, and this is what I tell my students, the most important part of prompting is what you initially type into ChatGPT or another tool. That very first thing you type in, the information you enter first has a very strong effect on everything that comes afterwards. Multiple studies over the past couple of years have shown that your first prompt and the details you provide in that first prompt most strongly affects all subsequent output from a large language model in a single chat session. So when you type in a prompt to ChatGPT or Google Gemini, the tools always perform a semantic analysis on the provided prompt. They're not looking for exact textual matches. That's very different from how you search in Google. These tools are trying to understand entire sentences and their semantic structure. And they use something called a self-attention decoder to translate your prompt into that generated output. And the quality of that prompt is really important. The details and specifics of the prompt have a measurable impact on the quality of the output the large language model generates for you. So detail, context, really important to these large language models to get useful and hopefully factually correct answers. So there's a couple of strategies you can use to create high quality prompts to give these tools the information they need to deliver results you actually want. So first up, be specific. If I go to an auto mechanic and say, my car is dead, fix it, that's not going to be very helpful to the mechanic. Without specific details, the mechanic can only guess at what the problem might be. But if we go into the mechanic and say, my car started vibrating, and then the engine started sputtering, and the engine stopped, and I was able to pull over, and I got the car started again, but then when I got it started again, it sputtered some and then stalled out again. That gives the mechanic a lot more information to go on. And they'll start by looking at the fuel injector because that's what their internal model and in their brain and tells them from experience is the most likely culprit. So let me give you an example. Let me give you an example of a minimal effort prompt that gives me okay to kind of minimal effort results. The prompt is list 10 ideas for a paper about substance misuse prevention. And it gives me 10 generic, though maybe useful responses. But if I put more effort into crafting a prompt about the same topic, I get much better results. Now the prompt is you're an expert in substance misuse prevention in Lincoln, Nebraska. You've spoken at national conferences and testified in front of the Nebraska unicameral on the topic. You speak in a formal academic style. List 10 ideas for a paper that's targeted to the population of Lancaster County in Nebraska and are relevant to the daily public health work of the public health professionals there. Well, all of a sudden, the results look like titles for a real publishable paper using domain-specific terminology, and each title has a specificity of focus that the previous list lacked. And generative AI can be a great teaching assistant or tutor or help you do research. I use it a lot for that purpose. But if I ask a really broad question, I'm going to get a broad response with with a lot of detail that's not necessarily useful to my specific aims and objectives. So here I said, how can I learn about the chemistry of nitazines? And it gives me all this stuff about core chemical structure. I'm not a chemist. I don't understand this. So if I instead say, if I provide more context that I need to give a presentation on nitazines to policymakers in Jefferson City, Missouri, create an outline of a 1-month plan to help me learn about them and their misuse by use populations, I'm giving a lot more details, and it's going to give me a concrete outline that I can follow for the next month to help me actually build my presentation. So being specific about your aims and objectives and target populations, anything like that, really, really important to getting what you want much faster. Next up, start with an action word. Create, write, make, generate. These action words will direct the large language model to generate a useful and actionable output. Because if you don't include these action words, the LLM will give you information that's relevant. It's like information dumping, but not specifically useful to solve a problem or take action. So here's a brief example of this. I asked Claude, can you tell me about economic policy? And then it gives me all sorts of general information, very high level stuff. It doesn't really help me better understand the topic in the context of my current work. But if instead I say create a 1-week learning plan to learn basic economic policy so I can write about it in a scientific article focusing on wage gaps in Overland Park, Kansas, and how they affect long-term health outcomes, and I only have like an hour a day to do this, I'm going to get something that is actionable, right? I'm not just getting an information dump. I'm getting a step-by-step outline to this process. And this is much more actionable than what I got with my first prompt without one of these words or verbs in it near the beginning of the prompt. Next technique, role play, or more specifically, tell it who it is, and therefore kind of what it can do and how it should write. So remember that first example I showed you a couple of minutes ago for an idea about a paper about substance misuse? When I said, give me ideas, it gave me some vague ideas. But when I said, you're an expert in this topic and here's your background, it gave me a richer set of responses that were much more reflective of what I wanted to do it in the first place. So don't be afraid to tell it who its audience is, whether it's an audience of high school students or researchers at an epidemiology conference or policymakers in Lansing, right? Tell it who its audience is, tell it who it is as well, and you'll get a much more targeted targeted writing style and much better responses. So here's an example. I said, you're a principal, high school principal in Black Hawk County, Indiana. Read this press release about a proposed bill on nitizen trafficking, take key points from the bill, and write a brief letter to parents about how this bill will impact their children if passed. And so the results, I think, are actually useful because the large language model, ChatGPT in this case, has a context that says, this is who you are. And then it infers a kind of writing style and does what you want and gives you an audience appropriate response. So that's all. It's not going to actually make reduce hallucinations or anything like that, but or give it make it smarter by saying you're an expert. It just infers a kind of writing style and an understanding of the topic that's a bit broader and better. All right. So the last thing you should try to do always is reduce confabulations or hallucinations. And I just don't like the term hallucination because large language models don't have physical bodies. And hallucination means seeing something outside the physical body. And there are real dangers with the anthropomorphization of AI. And I'll talk more about harms later on. So I go with the term confabulation, which means making something up when there's a gap in available knowledge, which is exactly what large language models do. But most people say hallucinations because that's what caught on the text press, but both words work. Anyway, all large language models make stuff up. They can make up totally false facts, or more commonly these days, references to studies, papers, or books that don't actually exist. And this has become less and less of a problem over time. But as you can see in this chart, ChatGPT 5 High, the most available or advanced model available in ChatGPT, has a hallucination rate of only 1.4% when generating output. But hallucination rate of 1.4% still means that out of 100 references GPT-5 High shows you, 1.4 of them are bound to be totally made up. So how do we mitigate this and get the most factually accurate information and citations when we're asking questions from these tools? Well, there are two strategies. First of all, enable web search in whatever tool you are using. This is not on by default, especially if you're using the free version of ChatGPT or Claude. It is turned on by default in Google Gemini because Google has its giant search engine. And you're going to want to enable this because it'll force the large language model to go out and search the web when creating your answers, rather than just thinking it knows what the appropriate references or sources are. And because large language models can be weirdly lazy, you also have to tell the large language model to search the web in your prompt. If you don't, it might not actually search the web, even though you have web search enabled. So telling the model to focus on high quality sources not only improves the quality of the output, but also helps to ground the output in evidence-based research. Now, alternatively, if you want a well-researched report with minimal hallucinations as your answer, you should use the deep research options available in ChatGPT, Claude, or Gemini. These tools really require a thoughtful and detailed prompt up front, and they might ask you one or two follow-up questions before going off for anywhere from 5 to 15 minutes to search the web and put together a detailed report for you. And these reports, I will tell you, are surprisingly accurate and insightful. I was giving a training series to the Overdose Response Service this past summer. That's a partnership between the CDC Foundation and public health and law enforcement professionals around the country. And I ran a deep research report on submersibles as drug trafficking tools. And I showed it to this group as an example of what these deep research reports could do. And one of the group members served in the Navy and then in the DEA, and continues to serve in the DEA. And he was really impressed with the quality and accuracy of these reports. He was like, this is 100% dead on. How did it know this? And so the quality is really high. Now, it's important to know that these reports are only available in really limited quantities, if you don't pay for one of these services, like you get maybe 2, maybe 3 deep research reports a month, but they're really useful if you need to do some deep digging into a topic and have complex research questions answered. Okay, so to recap the strategies, provide useful context right up front. Be specific about your goals and aims. Start with an action word, role play, tell it who it is for writing style, and then also force web search whenever possible. Including all 5 of these elements will make your prompts better and the output from the large language model from the generative AI tool much more useful to you. All right. So here's what we're going to do. We're going to do an activity. Hooray. Everybody loves activities, right? You're going to design an intervention with the help of ChatGPT or Google Gemini or Claude. So what I'd like you to do is fire up your web browser or your phone if you have the apps on your phone. Go to ChatGPT, go to Google Gemini, go to Claude. It doesn't matter which one you use. You don't have to have an account at all. You don't have to have an account. You can do this for free. Just go to one of these three websites, ChatGPT, Google Gemini, or Claude, whichever one you want, doesn't matter, and ask it to design a public health intervention on a topic of your choice. I'll give you some examples in just a second, but just ask it to design an intervention. And remember, how you write your prompt is important. So here's some very sample, basic prompts you can use, like what are three evidence-based interventions to prevent binge drinking at Kansas State? Or outline a community-based mental health support program for families affected by job loss in Burlew Springs, Missouri. Or design a community outreach program to reduce e-cigarette and vape use in Union County, Iowa, excuse me. I don't know why I said Idaho. So Iowa. So these are just some example prompts. You're going to want to do a more detailed prompt on this. I'm going to pull up the 5 things you should try to include in your prompt in just a second. So I'm going to give you 5 minutes to do this. I'm going to give you 5 minutes to do it. I will sit quietly here. If you have any questions, you can type them in the text chat. Otherwise, go out to one of these large language model tools, ChatGPT, Claude, Gemini, ask it to help you design an intervention. And when we're done, I'd love it if a couple of you would just sort of copy and paste your prompts into the chat and give me feedback on how that went for you. Okay. Thank you, Melissa, very much. So Melissa said design 3 evidence-based public health intervention strategies for problem gambling prevention in higher education based on the SPF PFS model and recommendations from the National Council on Problem Gambling. Results are really good. So did it accurately understand or seem to accurately understand the SPF PFS model, Melissa?
Yeah, it did. It gave 3 strategies that we use for alcohol prevention. And so I knew that it was legit. That's why I used that prompt because I knew, what I was looking for. So, yeah.
That's great, though. Yeah, that's a great strategy to use a framework or tool set that you are familiar with to make sure that it's going to result in something that's actually accurate and useful, rather than sort of flying blind in there. That's awesome. I'm glad that was really helpful. Anybody else want to share their prompt and or sort of experiences, results with that? And if you don't, it's perfectly fine. But it's always good to see the work that other people do, because I think that helps us all get a better understanding, certainly within the context of substance misuse and other sort of prevention strategies. Anybody else? Okay. If you don't, that's perfectly fine. I'm going to have a sip of water and move on. But hopefully the exercise was useful. Oh, Michelle, thank you. How to design a prevention program to reduce the amount of vaping in middle school children in Northwest Ohio based on grant funding and DARE programming. Very good. Hopefully the results were useful for both you and Courtney. Yeah, so it's also good to, again, you're giving detailed, specific contextual information, which I think in my experience, when we're talking about public health interventions or substance misuse interventions or any kind of behavior are super important because the social, economic, political context of one area is going to be very different from another area in the United States or other parts of the world. And I think by adding that in, it really helps the large language model focus on and get contextual details, which really strongly affect its output for you and make things really much more useful. I don't know. I think you were probably pretty specific, Michelle. I mean, you'd have to decide based on the quality and the results of that. But I think you were doing, I mean, you were telling it what your goal was, right? Design a prevention program around a specific topic, a target audience, middle school children, a geographic area, Northwest Ohio. And you gave it examples. You gave it a framework to work on, right? Existing DARE programming. And I think all of those things were quite specific. I mean, you'd probably still, everyone would still have to iterate through and go back and back and forth with the model. But I think that was pretty good right there. I think that was a good start. Okay, so hopefully that was useful to you. And again, you'll get a copy of these slides. So you'll have all this stuff in here afterwards to sort of refer back to. So I want to sort of spend a couple minutes talking about saving time we're using generative AI as an assistant for you. Because there's some things that generative AI is actually quite good at right now that can save you a lot of time in your daily public health and substance misuse prevention work. And I'm going to go over these relatively quickly, as some of you may already be using generative AI in this way. But if you're not, these are things that I do, and I think you can save, generative AI can be used as an assistant to save you time in your job in these areas. So, a surprisingly challenging task, I find, at least for me and my colleagues in public health, is how do we find time to keep up with recent studies that influence how we're supposed to do our jobs every day? I teach both health science communication and generative AI at Hopkins, and believe you me, there are a ton of new generative AI papers coming out every month. There's this prompt that I've developed here, and you can, obviously adjust it to your own needs, right? In this case, it says you're an expert in epidemiology of air pollution, and you're going to read a research paper and make sure that you create a summary that encapsulates the main findings, methodology, results, and implications. And I need it to be written in a way, because I am not an expert in epidemiology of air pollution, in a way that's written that I could understand this, right? Without having that kind of expertise. And this is a prompt that works well for me and my colleagues at Hopkins. And with small adjustments to this prompt, you can actually do this with 2 or maybe even 5 papers at a time. But as I mentioned before, large language models can sometimes be weirdly lazy, so you got to make sure it read the whole paper, like literally by asking it, did you read the whole thing? And again, I would say this is not a substitute for deep reading of papers, because sometimes important contextual details will be omitted. So it's really a better tool for getting through like a pile of articles really quickly and picking the ones that are most directly relevant to your job and reading those in close detail. Next up, summarizing qualitative survey detail. And I say qualitative because generative AI tools still aren't really great at math, except for maybe like symbolic math. And you're going to want to perform any kind of quantitative data analysis that you do in a tool like Excel. But where generative AI shines is in its ability to sift through lots of qualitative data really quickly. And I do this for the classes that I teach. Every term I teach at the Bloomberg School of Public Health, and I get for at least one of my classes over 600 course evaluation responses every year. I teach 5 different classes. I literally have thousands of evaluations that I'm supposed to review. And I already get summarized quantitative data, but instead of me reading 600, 1,000 responses to the open-ended questions like, how can you improve this course? I asked ChatGPT to do that work for me. And it does a really good job with this. It does a surprisingly good job. Now, you're probably going to run your prompt multiple times in separate chats for verification, just to make sure it's getting the same patterns at every single time. And again, because it's doing summarization, unique but potentially useful data might be missed. But again, multiple runs will still be faster than you reading through all the responses on your own. Using examples is a really powerful way to get better results from a large language model and to explore novel approaches or ideas for sort of program implementation, I think especially in the health sciences. So in this case, you could say, here's 3 successful proposals for maternal mortality interventions funded by the Kansas Health Foundation. Generate a list of 10 ideas for a new proposal focused on similar interventions, but with different methods. This is a very common thing in the health sciences when we're looking at public health interventions. And again, the tools like ChatGPT, Claude, Gemini will come up with many examples much faster than you'd be able to sort of generate them on your own. You can check limits. I do this when I have to write things for, grant proposals in particular. Like in this case, it's that I'm writing an op-ed on this topic for the St. Louis Post-Dispatch. I can only have 600 words. Will my topic be able to fit? What should I focus on? What should I avoid? And you can do this with any kind of writing, including grant proposals. And I regularly use generative AI as an assistant on grant proposals, asking it to look for potential holes in my approaches that reviewers might find and to help me address them. I also use it to help me condense my sometimes verbose writing into the limits required by a grant or conference speaking proposal for that matter. I think it's really, really helpful in this regard. And one of the most powerful ways you can use generative AI is to have it critically evaluate your work. I and many of my colleagues at Hopkins do this regularly. If you're working on a grant proposal, ask for critical feedback on the proposed design. If you're drafting a conference talk submission, ask for feedback from the perspective of someone on the content committee. Asking a generative AI tool to take the perspective of a third party evaluating your work can give you really strong insight into things you've overlooked, your blind spots, as it were. And if you use multiple tools like ChatGPT and Gemini to perform that same critical evaluation, you can get even more comprehensive feedback. And I've done this on multiple successful grant proposals, and where I like have working with Claude and say, help me work on this and give me feedback. And then I put it in Google Gemini and say, what am I missing? What are the blind spots in here? What are gaps in my approach here? And then it gives me even more sort of, comprehensive feedback. And I honestly don't think I would have been awarded the grant had I not gone through this multi-tool critical review, or at least critical review from one tool at a time. So that's a really powerful strategy for really creating comprehensive grant proposals, or if you're writing a paper, or you're doing a report for your superiors, or for the sort of board at a state health department or something like that. It can really help you find your blind spots, and I do that a lot. But really, the most important thing you can do is experiment. Experiment. I'm giving you lots of advice. I'm giving you lots of tips and techniques, but you got to figure out what works what best for you, right? Where generative AI can be your assistant and help you out in your daily public health work, because my experience is only my experience, right? So if you're working with a tool and you're like, this is not good advice, this is not helpful, start another chat. Don't argue with it. Seriously, just start another chat. That's the best way to get out of you're like, this is garbage, this is not. Don't argue. Just start another chat and go from there and refine your prompt. If you like what was initially created, great. Then ask the generative AI to refine that existing output, because the first response, like many things in life, may not be the best or the most useful or the most appropriate response. So you got to experiment and sort of chat with the tools. Okay, so I want to finish up today with what I perceive as one of the biggest challenges that we as public health professionals, or we as health scientists, or just being a human being face in our use of generative AI tools. There are very many, very real opportunities for harm in the use of generative AI. And when I teach about this topic, I deliver a 90-minute lecture that still only scratches the surface of this problem. And I'm going to try to give you the highlights in the next 10 minutes. And just as a brief warning, we're going to talk about harms from multiple perspectives here. So some of the content may be uncomfortable or even a little bit upsetting. So large language models are tools of untruth and seduction. Remember, generative AI tools like ChatGPT or Claude are prediction machines. I talked about that in the beginning of the presentation. They generate probabilities, not certainties. And because they create highly persuasive and human-sounding results, we assume that they are telling the truth, especially when we are first start using these tools, or we're novices who haven't really educated ourselves much about the tools. And generative AI's lack of truth is highly exploitable. A July 2025 study from researchers at Oxford, Stanford, and MIT showed that current AI chatbots from OpenAI, Meta, xAI, and Alibaba can make people change their political views after less than 10 minutes of conversation. GPT-4o in this case, which is now no longer used, was 41%, and GPT-4.5 was 52% more persuasive than when people were just presented with basic factual messaging on political topics. Because large language models can generate large amounts of relevant evidence and communicate it in an effective and understandable way, they're highly effective at changing minds and making those changes long lasting. And the study found that people retain their changed opinions around 40% of the time a month later, which is incredibly difficult to do, especially when you're talking about political topics. And this leads into what is probably the most obvious harm enabled by generative AI, the ability to create misinformation and disinformation. So misinformation is false or inaccurate information, just getting the facts wrong. Disinformation is false information which is deliberately intended to mislead or intentionally misstating the facts. And I think it's pretty obvious where both misinformation and disinformation come into play with generative AI. Generative AI is a creator of misinformation. It makes stuff up. That stuff may sound persuasive and correct, but it's not always true. And as consumers and users of generative AI, or really AI in general, or any tool or information found on the internet, we have to fact check the content that is generated. If ChatGPT cites a source, you better make sure that source is real. If Claude refers to a study, you better make sure the study actually exists and that Claude's understanding of the content of that study is accurate. Disinformation, however, is where generative AI, especially multimedia-based generative AI, can become deeply insidious. This image of of the late Pope Francis wearing a Balenciaga coat caused a lot of controversy when it first appeared online. When this image went viral, tens of thousands of people commended the Pope on his killer fashion sense, while an equal number condemned this as yet another example of the corrupt nature of the Catholic Church. Now, most people who saw this image thought it was real until they learned it was not. Now, while not intended as harmful disinformation, it was a distortion of the truth. The coat does not exist, and Pope Francis never wore a coat like this, but it sure looks like he did. And when we become conditioned to rapidly process large swaths of visual information as truth and truthful experience on platforms like Instagram, Facebook, and TikTok, we take imagery at face value. A photorealistic image generator that can visualize pretty much anything you can dream up can be very dangerous indeed. And deepfake videos, wherein a video is created of an individual saying or doing something they never did in reality, are a harbinger of this how do we really know if it's real future. And if you've ever used an AI image generator, you've probably noticed that the people in those generated images are usually smiling, even when that's not part of their culture or the situation would never call for smiles. This is what some AI researchers call the bias of the American smile. The fact that Americans smile a lot and a lot of the training data used for AI image generators comes from sites like Facebook and Instagram, and where people are living their best lives, and therefore most of the humans in AI generated images are smiling. The biases of the people who make these tools absolutely spill into the content that's generated by these tools. And some of the biases found in generative AI tools and their underlying large language models are more definitely more harmful to marginalized populations than non-marginalized ones. So for the last decade, AI researchers have found a common phenomenon when language models are trained on public data sets. And that is the model reflects the undesirable social biases in those data sets and often perpetuate harmful stereotypes because of the training data that's used. For example, if you've used Outlook or Gmail in the last couple of years, you've seen the tools want to help you write your messages faster using autocomplete. The same goes for word suggestions just above our keyboards on our Android phone or iPhones. And researchers at Microsoft have shown that these autocomplete tools often show gendered assumptions. So, for example, if you type, "I'm not feeling great, I'm going to the doctor's office," the autocomplete response would almost always include something like, "Let me know what he says," defaulting to he in all cases. Now, these models used in autocomplete tools tend to be a lot older than those found in tools like ChatGPT or Claude, but they're still used by hundreds of millions of people every day. And even after companies that make commercial chatbots have poured tens of millions of dollars into mitigating gender bias on things like occupations, a study released in July of last year from a team at the Technical University of Würzburg-Schweinfurt in Germany found that a wide range of models, including Claude and ChatGPT, advise women to ask for lower salaries than men, even when both have identical qualifications. And the researchers on the study pointedly noted that while companies like OpenAI use a technique called reinforcement learning to prevent these kinds of biases in their outputs, they can't fix the stereotypical correlations that the model has already learned during its training on public data sets. So gender is one obvious area of bias, and race is another. Racial bias is a common problem in a wide array of artificial intelligence systems, especially those that either generate images or try to match human faces to images in systems like law enforcement databases. An August 2024 study from a group of high school students, including my alma mater, Bellarmine College Preparatory in California, showed that the image generators in ChatGPT and Google Gemini generate a disproportionate number of white faces with happy emotions and a disproportionate number of black faces with unhappy emotions. Even the language that someone uses to type a prompt into a tool like ChatGPT can strongly affect its output. Another study from August 2024 by researchers at Oxford, Stanford, and the University of Chicago showed that language models assign considerably less prestigious jobs to speakers of African American English than to speakers of Standard American English, even though they are not overtly told that the speakers are African American. And similarly, when language models were asked to pass judgment on defendants who committed first-degree murder, they opted for the death penalty significantly more often when the defendants provided a statement in African American English rather than Standard American English, again, without being overtly told that the defendants were African American. And racial bias finds its way into seemingly more innocuous and mundane applications of AI as well. Just a quick question. How many of you turn on captions when you're in a Zoom or WebEx meeting or watching a show on a streaming service? I mean, I do. It just makes, I'm getting older, it's hard to hear. It just makes it easier, right, for me to follow along. Well, a December 2024 study by researchers at Northeastern, Pomona, and Stanford showed that there was a significant difference in the word error rate on major video conferencing platforms, including Zoom and WebEx and Google Meet. And the word error rate is the proportion of discrepancy between the results of human transcription and machine-generated transcription of the same audio. And the word error rate for non-native English speakers was higher than for native English speakers. And Black speakers had a higher word error rate than white, Asian, or Latino speakers on almost all the platforms. And this isn't just about accuracy when dictating an iMessage to Siri. This is about access to voice command-driven services that are increasingly common in healthcare and customer service. So I'd like to wrap up this section on harms in generative AI by looking at the broader environmental impact of these tools, because whether you use ChatGPT or not, these tools are starting to have a meaningful, measurable impact on the environment in which we live every day. The computational power required to train a 1.8 trillion parameter like GPT-4, parameter model, excuse me, like GPT-4 is enormous. Add to that the thousands of millions of people who use ChatGPT or Claude or Microsoft Copilot or Google Gemini every single month. Each of those questions, each of those searches, and each of those image or video generations requires additional and significant computational power. And compute is not self-sustaining. And it is not currently environmentally friendly. Alex de Vries, who's a data scientist at the Central Bank of the Netherlands, estimates that by 2027, next year, the current major AI players will use 85.4 terawatt hours of electricity. That is more than what countries like Finland, Chile, Greece, Ireland, and Israel use in an entire calendar year. Meta, the company that owns Facebook, Instagram, and WhatsApp, is building a new data center codenamed Hyperion that will be located in rural Louisiana. And this data center will be approximately 2/3 the size of the island of Manhattan in New York City when it's complete. And when fully operational, it is expected to use 5 gigawatts of power all by itself. In June of last year, Google and Brookfield Power signed a $3 billion agreement to deliver 670 megawatts of power from 2 hydroelectric dams in Pennsylvania, with an option to purchase up to 3 gigawatts of power from multiple dams in Pennsylvania under the same agreement. And Google will receive first option on power from these dams, and anything left over will then be routed to consumers. And these dams are part of the largest individual power grid in America, the PJM interconnection, which covers 13 states from Illinois to Tennessee, Virginia to New Jersey, and serves about 67 million consumers, including me, because I work at Johns Hopkins and have a home in Baltimore, in Frederick, Maryland, excuse me. And the PJM interconnection is already struggling to meet power demand from new data centers. The PJM interconnection currently has the most data centers of any power grid in the world. The demand for more data centers, for more power, for more compute is unsurprisingly causing prices to rise for consumers in areas hard hit by increased demand. In the PJM interconnection, for example, electricity prices rose more than 20% in 2025 due to both demand and capacity caps. And in July of last year, an energy affordability advocacy group named Powerlines reported that utility companies across the United States have sought regulatory approval for $29 billion in rate increases in the first half of 2025 alone. That's a 142% increase over the same period in 2024. Now, I know there's been a lot of alarm raised about around water use by these massive data centers that power not just generative AI, but all the websites we use every day, right? Amazon, Facebook, TikTok, all that stuff. And until recently, the numbers cited around water use were largely just estimates and seemed to be really bad, around 500 million gallons of water per year per data center. And a widely circulated story from the New York Times claimed that water's consumption from a recent metadata center built in Newton County, Georgia, had caused wells in nearby homes to run dry. In fact, it wasn't water usage in that case, but sediment buildup in groundwater from construction that caused the wells to run dry. Construction of these new massive data centers is much more of a problem than water consumption, at least here in the United States. So once this specific data center cited in this New York Times article went live, it was responsible for only 2% of Newton County's overall water consumption, while a local pharmaceutical manufacturing plant in the same county used 4% of the county's overall water supply. So Andy Masley, he's an AI researcher and about 2 months ago, released a very detailed report that he built using source data from across the United States, from actual data from individual municipalities and counties that did water consumption and tracked the breakdown and who was using it and who their clients were. And it showed that data centers in the US, including those running generative AI tools, use a fraction of the amount of water used by mining, forestry, livestock, steel, and of course, golf courses. However, the construction of AI data centers and their vast need for electricity in daily operations is a problem. Construction causes environmental impact, including sediment buildup that does affect local water supply and supply in the period shortly after construction, during construction, and shortly thereafter. And electricity companies are even returning to the use of coal as a fuel source to help keep up with demand from new and expanding data center buildouts. The UK news service, The Register, reported just about a month ago, in November of 2025, that coal usage by US electric companies has increased 20% in 2025 alone to largely meet data center power demands. And in February of 2025, Shalai Ren and his colleagues at UC Riverside and Caltech estimated that air pollution from building, running, and maintaining data centers that power tools like ChatGPT or Gemini resulted in $5.4 billion in public health costs since 2019, specifically around air pollution, with costs rising over 20% from 2022 to 2023. AI chips are getting bigger and more power hungry. Public, private, and commercial demand for generative AI services is likely to only increase in the coming years as the capability of generative AI becomes more powerful. The power of AI chipsets will continue to come with traditional fossil fuel-based costs and their impact on the environment and the public's health. So I think we all need to ask, what is our personal impact on this front? And how can we get these companies and our governments to take the environmental impact of non-sustaining compute into consideration and the economic impact of continually increasing consumer electricity prices? And again, want to remind you, I am speaking for myself here and not as a representative of Johns Hopkins or the Mid-America PTTC when I say, if the environmental impact and economic cost of massive data centers, or the fact that individual consumers are going to bear the brunt of the costs of data center build out is important to you, then vote. We will not get meaningful change on this front in the United States unless there is a change in the makeup of Congress. But, and there's always a but, isn't there? These are still powerful tools. They are the least useful, least capable generative AI tools we will use in our lifetimes. And they still have a place in our daily work, in our daily practice of public health. I use them daily, even though I understand what's going on behind the scenes. And even though I understand the risks and the public health impact and the economic impact and potential economic impact of this is important to me. So I think we just need to engage in the process with open eyes and an understanding of the biases and costs that might surface in what is generated for us. So I hope you will take what you learned from today and go chat with a GPT. These are powerful tools for ideation, for summarization, for feedback, to be your assistant of everyday public health practice. Just make sure that you remember these are prediction engines, not perfect oracles of the future without an environmental cost. So I'd be happy in our remaining, I think we've got like 5 minutes left, be happy to take questions that you might have, concerns that you might have, things you want to talk about, and then we'll wrap it up from there. All right, let's see. A couple things about, data centers. You can always work with your local state governments, your local county councils. In Frederick, Maryland, where my house is, there's been a couple data center proposals, and people have worked very hard to not just necessarily block these data center proposals, but to actually have rules and regulations around them that don't just blanket tax breaks to companies building data centers, because most data centers don't provide a lot of jobs or positive economic impact for the areas in which they are built, but also to worry about consumer spending and consumer pricing and to push back on forcing companies like OpenAI or Anthropic or Google to actually bear the cost or some of the cost of the data center build out. So it does work locally, but be involved and know about this because it is going to affect you and where you are. Um, Beata wants to know, once you get a result from AI, specifically when asking to create a presentation, for instance, what's the best way to extract the results in a usable form? You currently do a lot of copy and paste. And some of the information you got from your prompt was an HTML code, how to actually see what this is. All right, so here's one of the real challenges. If you're trying to build a presentation, these tools aren't really good at that. Inside of Microsoft Office, if you happen to use Microsoft Office and you happen to have Microsoft Copilot embedded, it will build a presentation for you. But if you go to ChatGPT or you go to Claude or Gemini and you're using the free versions of the tools, it will generate usually what we call Markdown. Markdown is a very simple Markdown language or markup language with like pound signs and dashes and asterisks to help emphasize things like lists and bolding and things like that, but they won't really create a good visual presentation for you. This is where paying for these tools makes all the difference in the world. And I pay for all these tools because I teach about this and I need to keep track of it. But I will tell you that of the current tools that are out there, Claude is the best at making Word documents or PowerPoint presentations from your conversations, actually real documents you can use. Google using a tool called Notebook LM is pretty good. Google Gemini exporting to Google Docs or Google Presentations is okay, but it still gives you a lot of garbage in there. Claude is the best. ChatGPT is the least effective at doing this, in my experience. So these tools aren't really designed. These tools are designed around text. So when they generate something like make me a presentation, they're focusing on text more than anything else. Except for Claude, Claude's programmers, developers have done some really clever things to help use software development libraries to actually create a real PowerPoint file out of that. Again, you can do similar things in ChatGPT if you're using the paid version. The free version, it doesn't really do it at all. So I think this is one of the sort of realities of working with these tools is that initially they're all given away for free. And over time, because these companies have multi-billion or almost trillion-dollar valuations, they need to prove that they can make money. So they've started moving their best tools and their best models, which give you the best output and the best responses, behind their paywalls. You have to pay for them in order to get access to the best tools and the best outputs, which is really, really frustrating, I understand. But I would also argue that most of these tools are available to you for about $20 a month. And I understand, I said to my students, I understand you're struggling students, you can't necessarily afford it, but is $20 a month worth an hour of your time that you might save from using these tools? It is for me. I would imagine that it is for you as well as public health professionals. So hopefully that answers your question, Beata. Beth asks on how can we minimize the environmental impact or remove stereotyping in AI beyond not simply using these tools? Yeah, so that is a great question. I mean, again, we have to have a change in our local state houses, and we have to have a change in our federal Congress as well. That's the only way we're going to see action on, not allowing companies like XAI to run unregulated, unfiltered methane gas generators to power their data centers because they're like, we can't move fast enough with power companies. We're going to put literally jet engines outside our data centers and run them to power our data centers. That is what's happening right now. And without local and state and federal regulation, that is going to continue to happen. So I think that's what we have to do. We can also choose. There's a lot about model choice. If you're asking a large language model tool like ChatGPT to just rewrite something, use their instant model. There's a model picker in the upper left corner of ChatGPT, and if I had more time, I could go into this. But using those faster models uses less energy, uses less compute, is less bad for the environment. Don't do things like generate videos. Don't do things like generate images because those take up a lot of processing power that will contribute to environmental sort of problems. I also teach developers about how to do this kind of stuff, and I say to them, look, you vote with your wallet. right? If a company is more aggressive, more environmentally responsible, and deals with issues like bias, and they talk about using how they address bias in their work, and I'll tell you that of the leading large language model makers, Anthropic, who makes Claude, is the most closely aligned with my values on this front. Um, then you vote with your wallet. And if you have a company or a large organization that's going to use these tools, ask your providers and say, what are you doing about this? Because this is an area of concern for us, and we may not be able to use your tool if you don't address it. And the more pressure they get on that front, money talks, right? The more likely they are to address some of those issues on the back end, if that helps. Yeah. So I realize we're after time. So Gina asked, are there other trainings on AI that we could watch? I have given a couple of other talks to the Great Lakes PTTC. If you search up the Great Lakes PTTC, you can find out from them. You can bother Tyler as well and suggest that I come back. I can do a longer version of this talk. I also talk about using AI chatbots for data visualization and analysis. I love talking about this stuff. Yeah, so I could definitely talk about that stuff and just reach out to him. And Michelle, I'd love to talk about your question about cheating or quote cheating. This is a big issue at Johns Hopkins. I am on the committee that sort of focuses on this topic of, and basically our response when people are like, students are just cheating. It's like, well, you know what? If our assessments are so meaningless to them that they're going to cheat or quote cheat by using generative AI to do all their work, then we need to rethink our assessments instead of just taking this combative adversarial relationship with our students and saying, you're just going to cheat, so I'm just going to punish you. That is not going to lead to good education. And I have a student, a youngest son who just graduated high school, and the chat GPT reliance is a real thing. The brain rot is a real thing. I could probably talk for 45 minutes on that, but I know we're out of time.